Yeah, hi. A very good evening. So we are live now. I guess we are live, right? Let me just check out. Yeah. Okay, all set. Yeah. Hi, a very good evening. So, this is our fourth live session, and we'll be discussing a few multiple choice questions from the topic dental materials, right? So, we'll be covering a few multiple choice questions. I'll be discussing in detail pertaining to those questions, and also I'll be giving you explanations accordingly, right? So, yeah, Jagdish. Yeah, hi, Jagdish. A very good evening. So before that, I would like to just make a small announcement. So we're launching our new batch, our third batch, this June 11th, and we call it a Mission 5 batch, right? So we have oddly 5 to 6 months time, and we're launching this new batch starting from this coming Sunday, June 11th, right? And all the details for any further details, you can contact us, you can mail us at proudtobedentist@gmail.com, right? And regarding today's live session, so let me just directly go into the live session. So first I'll be discussing, I'll just explain you what I'm planning to do now. So I'll be discussing a few multiple choice questions one by one, and at the end of the session, so after maybe 15 or 20 minutes after I complete my side of discussion or my side of viewpoints, then I'll start taking up questions. If in case you have any queries, you can comment here, or you can even mail us at proudtobedentist@gmail.com. If at all I know the answers, then I'll go ahead, I'll answer, I'll explain you in detail. If at all I need to refer any other books, any other standard books, then definitely I will refer and I will come up with appropriate answers in the next consecutive live session, right? So here we go. And also we have another comment. Yeah, hi Shruti. Sir, how to manipulate amalgam so as to eliminate gamma 2 phase? Okay, I'll discuss all those questions at the end of this session, right? So coming to the first question which I wanted to discuss, cold welding is accompanied by. The question is, cold welding is accompanied by options. Option A, increased resiliency. Option B, fracture resistance. Option C, strain hardening or work hardening. Option D, none. So, first of all, what is cold welding? So, cold welding is nothing but, see, as the term itself indicates, it's welding process. So cold welding means welding which is done at room temperature, right? That's it. So usually whenever we hear across the term welding, we often think of some heat or pressure which is being used as an agent in order to fuse two components of metals, right? But in case of cold welding, the same fusion of two component metals is done at room temperature, hence it's called as cold welding, right? And this cold welding is employed when we are compacting a direct filling gold restorative material, right? So the beauty of this direct filling gold restorative material is that the different layers of gold, the different components of gold can be cold welded. So cold welding, to be straight, it's nothing but plastic deformation. It's a process of plastic deformation due to application of condensation forces or compaction forces, right? So as a result of this cold welding, there is usually a strain hardening, or it is accompanied by strain hardening or work hardening, right? We'll discuss that a bit later. But during this process of cold welding, when you try to condense material using a compactor, using a suitable compactor, then the intimate fusion between different components of gold is being made possible because of metallic bond that exists between the gold. So this metallic bond is nothing but due to interaction of electrons present in the valence shells of these gold atoms, right? And as a result of their interaction, there is metallic bond formation which is responsible for a fusion of different increments of gold, right? By the way, gold is available in different forms such as ropes, pellets, powder, sheets, corrugated gold, gold foil, etc., right? So different forms of gold are also available, and the different synonyms for these different forms of gold are also equally important, right? So coming to the question again, cold welding is accompanied by. So I've discussed in brief about cold welding, right? So after this cold welding, what's happening is, see, let me just briefly explain you. Whenever you do cold welding, so there are certain dislocations or imperfections which are being created within the metal, right? So because of creation of these dislocations which are created here and there, they mutually impede each other's movement. The movement of these dislocations is impeded as a result. So as we keep on cold welding, what happens is more number of dislocations are created, and as a result more amount of stress has to be placed on the metal in order to create movement of these dislocations, which helps in plastic deformation, right? See, cold welding leads to plastic deformation, right? The plastic deformation in the sense change in the surface structure integrity, and this plastic deformation is possible only when there is movement of these dislocations, right? So as cold welding is done, there are certain dislocations which are being created, and these dislocations mutually impede their movement, and as a result what happens is, as we keep on cold welding, number of dislocations increase. As a result, the amount of stress that is required in order to produce plastic deformation also increases, and this forms the basis for strain hardening or work hardening. So this explanatory part is given in very brief manner in Phillips, and even they have explained in Phillips that the scope of explanation of this particular area is beyond this textbook. So they haven't really given us the details of this strain hardening or work hardening, but they have just mentioned that as a result of cold welding, there is creation of dislocations, and these dislocations which mutually impede each other movements. As a result, what happens is there is increased stress, which leads to further impediment in the movement of these dislocations. As a result, this entire concept forms the basis for the plastic deformation, and also forms the basis for strain hardening or work hardening. I know it's a bit difficult to understand this concept, but to put it simple, as I mentioned, it's cold welding, creation of dislocations, mutual impediment in their movement. As a result, more amount of stress has to be incorporated, and as a result of this, there is something called as strain hardening or work hardening. So this strain hardening or work hardening, as mentioned, it's nothing but increase in certain properties of metals. So that increase in properties include increase in strength, increase in toughness, and decrease in ductility or percentage elongation. So these are some of the benefits which we can achieve from this process called as strain hardening or work hardening. By the way, strain hardening, the synonym for this is work hardening, right? So this strain hardening or work hardening is usually accompanied by cold welding, right? So coming to the question now, cold welding is accompanied by increased resiliency, fracture resistance, strain hardening, none. So obviously it's option C, strain hardening or work hardening, right? Hope it's clear, right? So I discussed in brief about cold welding, and also I've discussed in brief about strain hardening and work hardening, right? And see, the basis for all this is you need to understand the key term first. So for you to understand what the term is, it's pretty easy. Just open your Phillips, go through the key terms given in the textbook, try to understand them rather than memorizing them. As I mentioned in one of the previous videos, see, you have this luxury of not by hearting things, since it's not an university exam. It's a multiple choice question based, objective based test, right? So you have that luxury of not by hearting things. You can just understand the concept and analyze it, process it, and keep that in your memory. So that's the beauty of entrance, right? You need not really by heart it blindly, right? You need not by heart the definitions for that matter, right? So go through the key terms given in Phillips, and they help you enormously in understanding the concept, right? And we have several questions in previous entrance papers where they have asked about various physical properties, the key terms pertaining to various physical properties like yield point, resiliency, fracture toughness, ultimate tensile strength, and whatnot. So you can find all that information in the key points in Phillips, right? So hope it's clear, right? And moving on to the next question. Retention of a direct filling gold in cavity is attributed to options: ductility, metallic bond, compaction or condensation forces, and option D, all of the above. So the question is, retention of this direct filling gold in a cavity is attributed to. So we have options: ductility, metallic bond, compaction, and all of the above. See, as I mentioned previously, the retention of direct filling gold in a cavity is possible only because of the metallic bond that's present between different increments. See, gold we place it in increments, right? So once you place one increment of gold, you're able to place the other increment, and that other increment is able to retain in the cavity because of a formation of metallic bond between different increments of gold. And this metallic bond formation is influenced by the amount of force or the amount of condensation pressure you apply when placing direct filling gold, right? So obviously metallic bond, compaction, condensation forces play a role in retention. And coming to ductility, so how does ductility of gold help in retaining gold in a cavity? See, as a fact of matter, gold is one of the materials which has greatest ductility and malleability. So by the way, ductility is nothing but ability of a given metal to draw it into thin wires, right? Whereas malleability is ability of a metal to make it into thin sheets, to be able to compress that material into thin sheets. That's malleability, right? So as I mentioned, gold has greatest or highest values in terms of ductility. So this ductility, what happens is the moment you place gold in a cavity, for example, assume these hands as walls of cavity. The moment you place gold here in this area, and once you try to condense it, what happens? Because of its property of ductility, it expands between these walls. So the gold present expands between the walls and gets wedged between these walls, right? So ductility property helps gold in retaining in the cavity, right? So coming to the question again, along with options, retention of direct filling gold in a cavity is attributed to ductility, the metallic bond between different increments of gold, and most importantly, the condensation or compaction forces, right? So all of the above options would be appropriate in adding to the retention of gold in a given cavity, right? Hope it's clear. Now let's move on to third question. Dry and wet calcination are used in manufacturing process of. I guess we have some comments. Let me just go through them before going to the third question. Sayeri Hussain, sir, it would be really helpful if you give us a mnemonic for remembering all the composite restorations, DBA generations, names. Yeah, sure. Sayeri, I'll consider that request. We'll work on it, right? And Shrikant, sir, I'm finally Ryuji. Can you please make video on balanced occlusion and surveying? It will be very helpful for me. Okay, sure. We have prosthodontics schedule in the coming months, so definitely we'll work on it, Srikant, and we will have a video on balanced occlusion and surveying also, right? In fact, they're very important topics. We'll definitely have a video on that, right? And coming to the third question. So, dry and wet calcination are used in manufacturing process of. So, we have the question is dry and wet calcination are used in manufacturing of dash and dash respectively. So we have two blanks here. So options given are alpha and beta hemihydrate, beta and alpha hemihydrate, alpha and alpha modified hemihydrate, and none of the above. See, first of all, what is calcination? Calcination is nothing but a process of heating a given substance in presence of air or oxygen. So that's calcination. So when you call a calcination dry and when you call it wet, so we call it dry in absence of water or in absence of vapor, right? So dry calcination is something which is done in an open vessel, whereas wet calcination is something which is done in closed container under the influence of steam, right? So that is wet calcination. Now coming to gypsum products and their manufacturing procedure. So gypsum is, as you all know, it's calcium sulfate dihydrate, right? CaSO4 2H2O. So this calcium sulfate dihydrate, when partial amount of water is driven off from it, right? So through process of calcination at a temperature of around 110 to 130 degrees centigrade, even the temperatures are important, right? So during this process of calcination, half of the water is eliminated from the dihydrate, making it into hemihydrate, right? And if you keep on heating it, then it becomes hexagonal anhydrate and orthorhombic anhydrate, right? So that's not relevant now. So during the process of calcination, dry calcination is a method which is employed during manufacturing process of beta hemihydrate, whereas wet calcination, which is done in presence of 30% aqueous solution of calcium chloride and magnesium chloride, it's done in order to produce or manufacture alpha hemihydrate as well as alpha modified hemihydrate, right? So dry calcination is a method which is employed for beta hemihydrate, whereas wet calcination is a method which is employed for alpha and alpha modified hemihydrate, right? Hope it's clear. Now moving on to the fourth question. Contact angle is acute when? Option A. So we're talking about contact angle. So contact angle is acute when adhesive forces are dominant over cohesive forces. Option A. Option B. Cohesive forces are dominant over adhesive forces, right? Option B. And option C. Adhesive and cohesive forces are equal. Option D. None of the above. See, contact angle is an angle which is formed between the intersection point of a solid surface and a liquid. For example, you have a solid surface and you have a drop of water or mercury over it, right? So what happens? The interface or the intersection between this drop of water and the solid surface gives the contact angle, right? So contact angle decides the wettability or the wetting capacity of a given liquid. The lesser the contact angle, the greater the wetting. So just imagine this as a surface and this as a contact angle, right? So this is 90 degrees, this is 0, and this will be something 180, right? So when the contact angle is less, it means the fluid flow is more onto the surface of a given solid, right? When a contact angle is more, it means that the contact angle, the wetting capacity or the flow of a solid is very much poor. For example, take a mercury, right? So mercury has a very high contact angle, so it doesn't really flow onto a given surface, right? So contact angle decides the wettability, and to give you some values, we say when contact angle is 0, it is a perfect wetting, ideal case scenario. If the contact angle is 180, it's an extreme variant of an ideal case scenario where there is no wetting at all, right? So when you say that contact angle is less than 90 or acute, it means the wetting capacity of that given liquid is good. On the other hand, when the contact angle is greater than 90 or obtuse, then the wetting capacity of that particular liquid is very poor, right? So based on the contact angle, we can analyze and evaluate the ability of a given liquid to flow over a surface, right? Hope it's clear. So in the concept of contact angle, as I mentioned, we have a liquid on the surface of a solid, right? So within the liquid, so within this drop of liquid, there are certain forces acting between the same molecules, right? Yeah, we are having some comments. Yeah, that's fine. We'll look into that later. So yes, Ramesh, you're right. 0 degrees means a complete wetting. So when you have a drop of liquid on a surface, right? So within this drop of liquid, between the molecules of the same phase, you have something called as cohesive force. So cohesive force is nothing but the forces of attraction acting between molecules present in a same phase, right? And between the liquid and between the surface of a solid, you have some forces. These forces acting between molecules of different phases, right? One is liquid, one is solid, and these forces are called as adhesive forces, right? So we need to have a balance between these cohesive forces and adhesive forces in order to establish a contact angle, right? Only then a contact angle is established. And for a contact angle to be acute, in the sense less than 90, then obviously the adhesive forces should be greater than the cohesive forces acting within the liquid. On the other hand, if the contact angle is greater, then obviously it means the cohesive forces within the liquid are greater and dominant over the adhesive forces, right? So that's the concept here, right? So contact angle is acute when adhesive forces are dominant or cohesive forces, right? So among the given options, as I mentioned, option A, adhesive forces dominant over cohesive forces, that would be the appropriate answer, right? And another question, when a contact angle is obtuse, obviously the opposite would be true, where the cohesive forces are dominant over adhesive forces, right? Now let's move on to the next question. Yeah, the most biocompatible cement is, so we have different options. We have several questions on biocompatibility also, right? So the most biocompatible cement is zinc oxide eugenol, zinc phosphate cement, zinc polycarboxylate cement, silicate cement, right? It's a pretty straightforward question. I'm sure you know the answer, but let me just take this opportunity in order to explain you different concepts in biocompatibility. So what is a biocompatibility? So biocompatibility is nothing but the ability of a substance to be least irritating to a given biological tissue, right? So when you call a substance more biocompatible, it means it is more tissue friendly, talking in layman terms, right? So the greater the biocompatibility, the more tissue friendly it is, right? The lesser the biocompatibility, the more irritating that particular material to biological tissue, right? So biocompatibility in case of dental materials, in case of cements, for example, here we have option cements, right? So in terms of cements, biocompatibility, we're talking in terms of their irritation potential to the pulp, right? So cements are basically used to protect pulp, right? So we have various pulp protecting agents, right? So based on their pH. So this biocompatibility or the tissue friendliness of these cements depends upon their pH, which is an important factor in deciding their biocompatibility. Depending upon the pH, we have biocompatibility, right? So take for example silicate cements. So what is the pH of the liquid? In silicate cements you have aluminum silicate powder and phosphoric acid liquid, right? So what would be the pH of the cement once you start mixing? So the pH of the cement is less than 3 initially, and you know what, the pH remains acidic even after 1 month. So that's the acidic nature of the said cement, right? So as a result of which it has greater potential to cause irritation to the pulp, right? So silicate cement is considered to be the most or the least biocompatible material or most irritating cement to the pulp, right? On the other hand, let's go to the other extreme end. Take zinc oxide eugenol. So zinc oxide eugenol, as you know, it contains zinc oxide powder and eugenol broadly, right? So this eugenol has a special property, that is obtundent effect, nerve soothing effect, right? So because of the obtundent effect of eugenol and also because of a relatively high pH of zinc oxide eugenol cement, which is approximately 7 or close to neutral, the biocompatibility of these materials are comparatively excellent compared to other dental cements, right? So that's pertaining to zinc oxide eugenol. And if you take zinc phosphate cement, so obviously zinc phosphate cement contains phosphoric acid where the pH is extremely low and it has a potential to cause irritation, right? Hence that's the reason why when you place a zinc phosphate cement, we advise you to place a solution liner, that is varnish, right? So varnish is placed beneath zinc phosphate base in order to prevent entry of noxious stimuli in form of phosphoric acid towards pulp, right? So that's pertaining to zinc phosphate. And coming to zinc polycarboxylate cement, even though the pH of the liquid polyacrylic acid is extremely low, which is around 1.7, the moment you start mixing the zinc polycarboxylate cement, the pH rises rapidly. And another added advantage with zinc polycarboxylate cement is that the polyacrylic molecule size is comparatively larger than the size of dentinal tubules. As a result, the polyacrylic molecules, they block the dentinal tubules, right? In that way, they are comparatively biocompatible, in the sense they're biocompatible compared to zinc phosphate or silicate cements, right? And coming to GIC, so GIC, it's also acidic pH and even that's biocompatible comparatively, right? So we have different cements, and based on the pH and based on their irritation potential, we have different categories of cements, right? Different categories or different categories in terms of biocompatibility, right? So coming to the options mentioned here, so you have zinc oxide eugenol. So the question is, the most biocompatible material or the most biocompatible cement is zinc oxide eugenol, zinc phosphate, zinc polycarboxylate, and silicate cement. So among the given options, it is obviously zinc oxide eugenol, right? As Ramesh rightly mentioned. So it's a zinc oxide eugenol cement, right? So if at all they ask you the order, then what would be the order starting from the most irritating to the least irritating? So what would be the order in terms of biocompatibility? The most irritating cement would be obviously silicate cements, followed by zinc phosphate cement, followed by glass ionomer cement, followed by zinc polycarboxylate cement, followed by zinc oxide eugenol cement, right? So that's the order in terms of biocompatibility, right? So the reason why I chose this particular question is so that I'll have an opportunity to discuss in detail the biocompatibility. Yeah, sorry for the interruption. I had one call, so I just lost live for a moment, right? Hope you don't mind. Yeah. we'll just go ahead. Right. So far we have discussed around 5 multiple choice questions, right? I hope it's clear. I mean, how is it going? Are you able to follow what I'm saying? Let me just check out. This is live, right? So just lost the signal. Yeah, Janabi, I have a reply from you. Thank you. Okay, let me just check out whether it's a live streaming. Yeah, okay, right. Thank you for the response. I'm just checking out my laptop also so that I can view your comments well. Yes. Okay, fine. So far we have discussed 5 multiple choice questions, and what do you think? How is it going? Do you think we're doing good? Are you able to follow? Yeah, you have any questions pertaining to these topics, right? You can shoot your questions, and I'll be glad to answer your questions, right? So we discussed about cold welding. We discussed about strain hardening or work hardening. We discussed about the retentive aspect of direct filling gold, and also we have discussed about the calcination process, right? Dry and wet calcination. We also discussed about contact angle, which is very important. Contact angle, factors influencing contact angle, and also we discussed about the biocompatibility aspect of a few dental cements, right? Yeah, let me just go through the comments before I proceed. Yeah, okay, let me just answer these questions, and then let me just go through the rest of the questions, right? Yeah, sir, Shruti, we have a comment from Shruti. Sir, how to manipulate amalgam so as to eliminate gamma to phase? See, Shruti, it depends upon the selection of amalgam alloy. So you have this latest generation high copper alloys, right? So high copper alloys, there is nothing to do with manipulation, right? So high copper alloys inherently they have a more copper content, more than 30%, right? 6 to 30%. So they react with gamma 2 phase and eliminate that in form of eta phase, Cu6SN5, right? If I'm not wrong. So it has no relation with manipulation, right? So you can eliminate gamma 2 phase by proper selection of an alloy powder by choosing high copper alloys, right? And Saheri Hossein, Saheri will definitely do. I'll definitely try to get some mnemonics, or I'll produce some mnemonics pertaining to the topics which you have mentioned. Yeah, Shrikant, I hope I answered to your query. Yes, Ramesh, you have been active. Yes, good, Ramesh. Yeah, 0 degrees means complete wetting. 180, it means, there is no wetting whatever, right? Yeah. Ajaj, hi sir. Yeah, hi Ajaj, hope you're doing fine. Yeah. Kumari Ratimaran, sir, can you explain casting defects porosity? Kumari will do a separate video on casting defects, because casting defects as such is a very huge topic, and there is a lot of concept behind that. We have different types of casting defects, porosities, micro porosities. What do you call that? Presence of fin-like structures, micro fractures, bubbles, etc. Right? So we'll discuss all that extensively in a separate video, right? Sidikwa Ayesha. Hi Ayesha, what important topics to cover from ceramics? Ceramics, usually we have several questions from the synonyms, right? So we have different types of ceramics, machinable ceramics, castable ceramics, die core and all, right? So we have various names, right? So you can focus on different synonyms, different aspects pertaining to synonyms, and also we have questions pertaining to this three-dimensional CAD/CAM technology in ceramics, right? So you can even focus on that particular aspect. And also Ayesha, you need to focus on the basic composition of ceramics, and the important functions of the individual constituents, right? Constituents or composition. Hussein, thanks a lot sir, we'll be waiting for that video. Yeah, you're welcome Hussein. Okay, right. Yeah, so I've actually prepared only for 5 multiple choice questions. I didn't know how it would actually go. So if you think we're doing fine, I'll try to create simultaneously more and more multiple choice questions, and we'll have a discussion simultaneously, right? Yeah, we have one question from Jagadish. Conversion of monomer to polymerase, density changes. Sir, can you please explain it? So what is it related to, conversion of monomer to polymer? See, obviously, yeah, they say, for example, even in case of waxes or even in case of resins, whenever, in case of resins, as you asked, whenever there is conversion of monomer to polymer, see, monomer will be something like this. When a polymer is formed, a multiple chain formation, so the given volume will be decreased drastically, right? Obviously, we can anticipate some kind of volumetric shrinkage with conversion of monomer to polymer, that is during the process of polymerization. The value, as I said, is 21%, right? And density changes from 0.9 grams to 1.9. Yeah, that's what they're trying to say. Obviously, when the volume shrinks, so the material, for example, if a material is occupying 100 units, the monomer is occupying 100 units, polymer would occupy 50 units, right? So there is volumetric shrinkage, decrease in volume, and in that 50 units, if you observe, the density would be obviously higher because of multiple chain formation, right? So during polymerization, there is volumetric shrinkage, decrease in volume, and corresponding increase in the density, right? And where did you get those values from, Jagadish? Janabi, please make a video on composite restorative material. Yeah, sure, Janabi. I'll try to make a video on composite also. It's very extensive, but I'll try to give you some key points as well, right? Yeah. So anything else? Yeah, we'll also discuss few other properties pertinent. So what topic do you want me to discuss? So we'll go with waxes. So it's so how much time? It's already 31 minutes, right? Okay, it's given in pulse, Jagadish. Okay, we'll see. So I don't know what value is given in Phillips. We need to refer Phillips also once. But anyways, I hope you understood what I explained you pertaining to that, right? And one question to all of you. In dental waxes, so what is the composition of a basic wax? So a wax contains several components, right? So what is the basic composition of a wax and their properties, right? Even they are very important, right? So in wax, we have different components like paraffin wax, you have carnauba, candle. So basically, in wax, if I ask you a question pertaining to wax, for example, the drawback associated with a base material that can be modified using modifiers. For example, you have base material made of paraffin, right? So this paraffin wax inherently has low strength. It has this tendency of becoming flaky, and also you have this it doesn't have this surface gloss or smooth texture, right? In order to overcome these problems, what we're doing is we're adding certain modifiers to wax, right? So these modifiers which we add to wax include carnauba, candelilla wax, and we have beeswax, gum damer, which have different sources altogether. We have sources from petroleum products, plants, etc., right? So these modifiers are basically added in order to improve the properties of wax. Especially the main drawback with the paraffin wax is that it has highest coefficient of thermal expansion, right? So this highest coefficient of thermal expansion would obviously lead to distortion of the material, right? So which is not good, right? So in order to minimize distortion, we're adding modifiers such as carnauba wax, gum damer, right? So these decrease the coefficient of thermal expansion, these decrease the volumetric shrinkage, and also limit the flow of the wax material, right? And they also impart smoothness and glossiness to a given wax, right? So try to, when you're going through wax, try to focus on the composition of wax, important functions pertaining to the individual components, and also try to focus on the various drawbacks associated with the typical paraffin wax and the means which we take, or the steps which we take in order to overcome these particular drawbacks, right? And along with that, we have several other questions in wax. We have even question on what is the coefficient of thermal expansion, the value of CTE for paraffin wax, right? And also we have several questions on the types of wax, right? So we have these inlay waxes, we have various base plate waxes, and also we can anticipate several questions from waxes as well, right? So yes, we have a few comments. Yeah, it's MCQ, sir, from restored resins. Okay, Jagadish. Yeah, Janabi, composite part primer etching, all this process is very confusing. Yes, that's true, Janabi, but the concept is a lot more simpler, provided you understand it. So it seems to be confusing, but once you understand the basis for acid etching, the basis for primer, the basis for bonding agent, and the basis for applying composite restorative material, then it will be comparatively easy for you to follow, right? So for that you need to understand the basic concept. Definitely I'll make a video and I'll try to make it as simple as possible, right? Aishwarya, hi Aishwarya. Dental materials more memory based because it's a very volatile subject. And thank you so much for this video. It's a blessing. You're glad to hear that, Aishwarya. So before answering your query, okay, friends, let me just stop the multiple choice questions here, right? So I discussed around 5 to 6 multiple choice questions. If you think we're doing good, we'll do more and more multiple choice questions discussion in the coming weeks, in the coming live sessions, right? And I'll be taking up a few. Direct general questions from you, and if you have any queries, you can just comment them. I will reply accordingly, right? Aishwarya, coming to you, is dental materials more memory based? Definitely. Dental materials is like, so I just wanted to start the video with this, but somehow I got distracted. See, whenever you start with dental materials, make sure that, that's what I keep on saying, you have to have a notes. So this is my notes which I keep. A short notes, which is convenient, which is handy to carry. But if you have this short notes, you'll have a disadvantage of you'll have space constraints, right? So better if you have longer notes comparatively. You need to note down all values. You need to note down all values, and you need to memorize them. There is no alternative. There is no bypassing to that, right? So that's a harsh reality. So it's more of memory based. But let me tell you, Aishwarya, along with memory based, along with memorizing things, there is also a lot of concept. And this concept can be achieved only when you refer a standard textbook like Phillips or Craig. Let me just give you one example. If you're going through hardness, or if you're going through, for example, Janavi asked related priming, etching and all, right? So it's really very tough to by heart such things, by heart the names and all. See, names, examples, we need to memorize them. There is no other alternative. But understanding the concept is the key here rather than memorizing. So how do you understand the concept? It's given in detail along with various studies, quoting various studies in standard textbooks like Phillips. So once you go through them, once you understand the concept, you'll start enjoying the subject, right? So once you start enjoying the subject, it's like a win-win situation. You'll get benefited in the sense you'll understand easily, and you'll feel like going through it. You'll feel like studying more and more, right? So it's like you'll have that positive kind of attitude when you understand the concept, right? So refer a standard textbook always. That's what I or we keep on stressing. It's not just doing multiple choice questions or just by hearting stuff. It's about understanding concepts also, and that's possible only when you have a standard textbook reference, right? So Aishwarya, maintain a notes and simultaneously have a standard textbook reference. And as I keep on mentioning, see, I have my Phillips alongside, and I have this habit of keeping stick notes alongside these points, right? So you can see here I have posted one stick note here. So you just go through the subject there, the information given there, and note down key points there. You just paste a stick note, or for that matter you can also separately maintain notes and note down all important relevant points in your notes as well, right? So you need to put up a lot of effort, and only when you put up a lot of effort or so much of effort, you will get the fruits, right? It's not an easy job. If it were easy, anyone would do it easily, right? Yeah, hope I answered your query, Aishwarya, and thank you so much for your feedback, Aishwarya. Yeah. Janabi, okay, so thank you so much. You're welcome, Janabi. And what is the difference between surface area and surface energy? Kumari, surface area is nothing but the area which is present on a given surface, right? That we can call it as surface area. But surface energy is nothing but the inherent energy that's present on the surface of molecules, right? So this surface energy is the key and a deciding factor in promoting a wetting or whatever, right? So let me just give you an illustration so that you can understand that easily. So surface energy, for example, have you heard of conditioning? We have this etching and the concept of conditioning, right? So when you condition a cavity, so conditioning is something which is done, for example, when you're going for a restoration using GIC. When you go with the GIC restoration, we have this habit of conditioning a cavity with a 10% acrylic acid, right? So this conditioning is done in order to remove smear layer, right? So this smear layer is removed for what purpose? So this smear layer is removed in order to eliminate the impurities, smear layer, as well as to improve the surface energy. Always remember, greater the surface energy, greater the tendency for that surface to show good bonding, right? So surface energy is directly proportional or can be directly correlated to the bonding efficacy, right? So that's the rationale behind conditioning. And in Phillips there is beautifully given along with pictorial representation, surface energy and all is very well explained, right? So they have shown a few molecules, and the molecule or the atom which is present deep inside has almost zero surface energy because it is being attracted on all surfaces by various other atoms or molecules, right? On the other hand, the molecule or atom which is present superficially has greatest surface energy because it's still not in contact or it is left exposed, right? So as a result it has greater surface energy, right? So we have a lot many technicalities in that. We have a lot many technical terms discussed elaborately in Phillips, right? So we have that chapter adhesion and bonding where it is explained very well, right? Hope it's clear. So surface area, it's nothing but the area on a given surface, right? Circumference or the area on that surface. Whereas surface energy is something which has to do with the energetics of that particular surface, right? And it has direct correlation with the bonding as well, right? So that's pertaining to surface energy and surface area. And anything else? So next session, so every week we'll do one live session pertaining to multiple choice questions, and in next live session we'll try to cover more multiple choice questions, right? So I just covered 5. I thought like I would take more time to go in elaborate, but I covered them in around 15 to 20 minutes time, I guess, right? So we'll try to cover at least 10 multiple choice questions, right? It's not just about the number of multiple choice questions, but I will take that opportunity to explain you various concepts simultaneously, right? So from one multiple choice question we can go around and explain and discuss more than two or three important topics, right? So maybe I'll select 5 to 10 multiple choice questions in every live session and try to elaborate on the backdrop information, right? So on the backdrop information or on the backdrop topic, and just try to give you an overview, and we'll try to create more and more multiple choice questions, right? So before concluding the session, so we discussed 5 multiple choice questions, right? So from these 5 multiple choice questions, what more multiple choice questions can we anticipate? Let's now discuss them in brief. So cold welding, we discussed about cold welding, right? So cold welding is accompanied by, so cold welding, so what is cold welding? So we can have several options pertaining to cold welding. So cold welding, does it require heat, pressure, or none of the above, or all of the above, right? So we can have one question pertaining to cold welding, and also we can have one question pertaining to strain hardening or work hardening, the rationale behind strain hardening, and what properties are being improved in case of strain hardening. We can have even a multiple choice question from that. With strain hardening, as I mentioned, there is increase in toughness, strength, however decrease in ductility, right? So we can have multiple choice question from that topic as well, right? And also we discussed about metallic bond, the ductility. By the way, I just wanted to mention this point because it's quite interesting. The ductility of gold is so high that 1 ounce of gold, or 29 grams of gold, if I'm not wrong, it's 29 grams, I guess. So 29 grams of gold in form of a cylinder can be elongated to a length of approximately 100 kilometers. So that shows how ductile the gold is. Just 1 gram of gold, just 1 ounce of gold, or 29 grams of gold in form of a cylinder can be expanded or can be stretched to a length of more than 100 kilometers, right? And also remember the malleability aspect. While I was discussing pertaining to direct filling gold restorations, gold is so malleable that it can be made into a thin sheet which is almost transparent, and the thickness of this sheet is 0.00013 mm, right? So that's in range of microns, 0.13 microns or something, right? So that's the minimum thickness we can achieve with the gold, right? So that's pertaining to ductility and malleability. I found it very interesting, right? So I just wanted to share that information with you, right? And also we have discussed about dry and wet calcination, alpha and beta hemihydrate. We can have several questions, right? So we can have questions from the particle size, the particle configuration of the hemihydrates, and also we can have question on calcination procedure, the temperature ranges of calcination, And also, as I mentioned, we have the particle surface texture, right? So beta hemihydrate, alpha hemihydrate, we have gross differences in the particle sizes, in the particle surface texture and whatnot. We have several differences between them, and even these differences between alpha and beta hemihydrate are very, very important, right? And also we discussed about contact angle. We can have n number of questions from contact angle. We can have questions even from the contact angle values, contact angle value for mercury on glass slab, contact angle value for several materials. We have even some contact angle values for acrylic denture bases to saliva and whatnot. We have several questions from that aspect. And also we can have questions as one of our aspirants mentioned. As Ramesh rightly mentioned, we can also have questions from the values, right? So contact angle, acute, obtuse, 0, 180, right? So we can have questions from these areas also. And also I mentioned about the concept of adhesive forces and coercive forces. Obviously we can anticipate questions from these areas as well, right? And also regarding biocompatibility, so we can have n number of questions regarding pH of cements, regarding their biocompatible potential, regarding their irritation potential, and also regarding their composition. So cements as such is a very huge topic. Today I made some videos on cements, and also I made a video on ideal requirements of various properties of cements, right? So while going through those topics, what I found was there is a lot of information. In specific, I found out lot many area specification numbers. So we have a lot many area specification numbers, and when I browse the area website, we have a list of area specification numbers, but unfortunately there are many numbers which are missing in the website, right? So you can open that website, area website. So we have almost 100 to 200 materials covered with various numbers, and along with that you can make a note of all the area specification numbers which are given in Phillips and various other dental materials books, right? You can just note them and you can just memorize them. I don't know how far they can be asked in multiple choice question, but we can definitely anticipate, right? Because there is one question previously where they have asked the area specification number for amalgam, right? So area specification number for amalgam 1, and according to that, that's very important. So what does that 1 signify? So how much amount of contraction or expansion for amalgam is permitted starting from trituration till the setting time, right? So even that is very important, right? So area specification numbers, try to note them in a notes and try to memorize them as and when required. You can expect a question from that particular aspect, right? So we have another comment, Aishwarya. Sir, I came across a question in pulse. Strain that occurs when a material is stressed to proportional limit is. What is the difference between maximum flexibility and elastic limit? Actually, I made one video on stress strain graph. It's available in our E-classes website. See, elastic limit is the point till where the material regains its elasticity. That means it can come back to its original dimension. But plastic limit is something where the material doesn't come back to its original dimension till it fractures. So that is plasticity or plastic limit, whereas elastic limit is the point where it regains its original dimensions when the stress is released, right? And flexibility is a general term. So if you observe the dental materials key terms, they haven't mentioned flexibility as such as a key term. Flexibility is a general term which we use for any material which is elastic or flexible, right? So a question is strain that occurs when a material is stressed to proportional limit is. So proportional limit is the limit where, so you have this proportional limit on a stress strain graph where stress is directly proportional to strain. So till the proportional limit, the stress strain relation is directly proportional, and from this proportional limit to the yield point there is something called as elastic limit, right? So it's it will be quite confusing for you if I explain you in this fashion. You just need to observe that graph, stress strain graph. On the graph you have this proportional limit, you have this yield point, you have this elastic limit, you have this plastic limit, you have this ultimate tensile strength, fracture strength. All these points are mentioned in detail in that graph, right? You just go through the graph and also try to understand the area beneath the graph. because the area beneath the proportional limit indicates the toughness of a material, whereas the area beneath the plastic limit indicates I think I think that represents, see, the area beneath the elastic limit represents the resiliency, whereas the area beneath the plastic limit represents the toughness of a material. So once you understand that graph, once you understand those key points in the graph, then it will be easy for you to analyze those things, right? And before going through that graph, go through the key points as well. Aishwarya. Okay, Aishwarya, answer is maximum flexibility. Okay. Yeah, just go through that graph, go through the key points. I'm sure. I mean, if possible, just mail that query. You can just take a picture and screenshot, or take a screenshot of it and just mail me. If it's really very complex, then I'll try to get back to you, right? Yeah. Janabi, question is, which subject is next? Janavi, actually dental materials is very vast, so we are actually covering dental materials in two phases in our test series as well as in our e-classes, dental materials 1 and dental materials 2. So I've chosen few topics from the first part, so definitely in this next video, in the next live session, I'll choose more topics from the second part as well as in general, right? So everything pertaining to dental materials will be discussed in the next live session also, right? And from then we'll keep on changing the subjects. We'll keep on discussing more and more concepts elaborately, right? So that's it. So I think we have already, it's already 50 minutes, right? Since we started this live session. Okay. Yeah, okay, Jagdish, yes sir, that question is quite confusing. Okay, Jagdish, in that case, what you do is, Aishwarya Jagdish, you can just mail that question to me. I'll just refer it and I'll get back to you. You're welcome, Janabi. Yeah. So that's it. So I'll be staying for 10 more minutes. You guys have any questions, you can just shoot them. And by the way, as I promised you last week, so we'll be doing 2 live sessions per week. I know it's taking a lot of toll on my mental health, but definitely I'll do it for you, because even I am enjoying these live sessions, right? So I have this opportunity to interact with all of you live, and so I'll definitely do these live sessions. So as of now, we'll do 2 live sessions every week. One live session will try to cover only the multiple choice questions or related information, subject related information in that live session. And in the second live session in the same week, we'll take up some general topics. I'll just choose the topic and I'll post it on social media, or I can mail you, and based on that you can participate in the general topic live session as well as in the subject live session, right? So my advice to all of you is, whenever you start this or participate along with me in this live session, just carry a notes along with you. Just carry a notes and pen along with you, because once we complete this session, I was wondering, it's almost 1 hour long or 1.5 hour long, right? So for you to again go back through the entire video once again, so if you have missed the live session, then it will be fine, you can just go back through the entire video. But once you are going through live session again, it's really pain to go back through the entire video, right? So rather than that, you can just carry a notes with you and note down any relevant points. If at all you feel they are important, you can note them in your notes, so that it will be helpful for you during your revision time, or even when you're preparing for your respective entrance, right? So that's one advice I would like to give you all. And regarding the selection of topic, as of now we are following a weekly schedule. We are having our own schedule in our curriculum, in our course, so we'll be going based on that schedule, right? So if I give you an option, then I'll be definitely getting more and more topics from you, right? So as of now, we'll restrict to our course schedule. If you want, I'll just mail us our schedule. Yeah, I think okay. Yeah, I think we're still live, right? So we just lost power, but fortunately I still have my mobile data, so it's still going on live. So I was discussing something, I just lost it. Yeah, I was discussing something. I was talking about live sessions. Yeah, I was talking about the weekly schedule also, right? So I hope you can see me. I've just increased the brightness of my MacBook. Yeah. right? So you can just mail me. I'll give you my weekly schedule or our course schedule. You can just follow it for sake of these live sessions. Yeah, we have light. Thanks, Ma. So we have this slide also, right? So we'll just go based on that schedule as of now, and as we proceed, as we move on, we'll try to cover more and more topics based on the choice, based on your choice, and based on the interest, and based on the importance of that particular topic, right? So I'll just stay for another few minutes. So you have any questions, you can shoot. I'll be happy to answer them, right? We have some comments here. Yeah, right. Janabi, okay, so thank you. You're welcome, Janabi. Aishwarya, we love interacting as well. Thank you so much. Yes, glad to hear that, Aishwarya. And thank you for voicing your opinion as well, right? So see you guys next time. So I'll just wind up. So we'll meet again this Saturday or Friday. I'll just announce the schedule again. We'll try to standardize the schedule also. We'll just do live sessions on 2 days, 2 fixed days every week, so that it will be convenient for you also to follow it, right? So rather than me jumbling up the days, I'll try to give a fixed schedule, like every Wednesday or Saturday or every Wednesday or Friday. I'll work on it, and I'll decide, and I'll let you know definitely. So we'll just meet in the next live session this coming Friday or Saturday with a general topic, right? So hope you have understood something, and I hope you got something important, some relevant important points in the entrance point of view, right? And thank you so much for joining me live. And anything else, I'll just stay for a few more minutes. You have any comments, you have any questions, you can just post them. Yeah, fine. So this live session, we had a lot many interruptions. I had previously one call, so as a result there was disconnection. Now there is power cut. Anyways, it's fine, right? So these are all part of experiences, right? So I'll just wind up. So we'll meet you again next time. So glad you enjoyed this session. That's more important. It's not just about listening seriously. That's what even my dad said before I started this session. Don't be too serious. Just keep on cracking jokes. But I didn't crack any jokes, right? So we need to enjoy what we are doing. That's the key. And only once we enjoy, we really would love to do it again and again, right? That's the key. That's the key here. So hope you have enjoyed the live session, and we'll come up with more live sessions in the consecutive days. And thank you so much for joining me. Love you all. Have a pleasant sleep and good night, right? Keep smiling.